Okay, we'll continue now from where we left off. The last thing, I had to put the volume down for the TV. The microphone catches everything. Okay, so we created our floors. Next thing is now we're gonna create these some more detailed breakup edges by using the exposed faces and scattering some points. So let's do something like this now. We can create a little box here on this right side. Let's call it outer walls, which is going to be driven by some random values, which we're going to put them now here. The way I didn't directly put them inside the box values, I put it now here, created two floats for width. So let's call this out sizes. Let's keep the case sensitivity running in case we copy paste some of our nodes expressions. Sorry. So let's create a delete node and let's bring in the remove insides. Where is it? Here. So we can also remove this, rename this to remove inside. Okay, so delete. So I'm just going to keep now, if I go here like this, I just want to keep these exposed faces based on normal. So I can say delete selected primitives based on normal facing upwards. And then if I visualize this and start bringing this down, okay, so then it's just going to give me faces like this. Okay, faces pointing upwards. Okay, and now I'm going to put, let's put the background color to light. I don't like to work in dark. Okay, and now I'm going to get rid of some of those internal edges. So to do that, you can drop in a divide sub and click on remove shared edges, and then you also get nice clean geo. Okay. Now I'm going to remove the polygons. So I'm going to go ends, because I want to scatter points on the edges. So now we were here and using a divide to get rid of the internal connections and ends. Now I have the edges extracted. Now I'm going to scatter points. So in my scenes, I'm scattering 75 points. We really don't need to use relaxed iterations. We just need something total random. Now we're going to do copied points again. So for each, actually, do we really need to do for each? This could be just we could have done this here, I guess. It looks like I did many different ways of doing one thing, but let's stick to what we did. For each point, okay, so I get one here. I'll put a null. I'm gonna name this randomize. Okay, I think we may as well just improve this part after we do it the way I did it first. Copy the points. Okay, so this is the points, this is the geo. So what I did is, like I said, I created edit parameter interface. I create two floats. So you can use float vector 2, and we can name the size. Again, Houdini can wear many hats. There are many ways to do one thing. I'm just creating random numbers here for each iteration. So what does this do? It's not, you need to digest this from inside out. So I'm using the point position that each of these loops, each of these points, right? I have 75 points here. I'm using the point position to create a random number here. This is what it says. Point randomize, right? So when I do the double quote dot slash, it's going to show me what available nodes that are in the seam. And then I go randomize, and then I say fetch the point position of the point 0. There's only one anyway because it's in a loop. Then which I could have done it here too, and then output that as a p scale, scale actually, but we did it this way, so it's fine. Which I'll show now. Actually, this kind of makes more sense. And now let's do the other thing, which is the other right here. Okay, and now my size is just always super tall. So I'm just basically changing its width. Okay, not height, but I'm randomizing its thickness. So now I'm saying take this guy and paste it here, right? This one, paste, take this guy, paste it, this one here. So basically for each point it's going to give me, it's supposed to give me a different width and height. If I look from here, there are different sizes. So now why did I make it like this? I'm not entirely sure, but let's do it the other way, so it's just obviously clear as well. So I can do the same thing here. I can do a wrangle. You can bring this here, say randomize, scale. This is almost the same expression, so let's paste it for now, and let's say vector at scale. Okay, so it's gonna error. Let's do this. So I think I'm going to type this again. So let's go actually. So like this, slash. All right. So let's say something like this. F at vector x. I want to create a random value based on point position. So okay, this is the part first I'm changing. Instead of referencing it, I'm going to directly say is the point position at p. Okay, so this will give me vector x random values 0 to 1. Then I am fitting this to 2.5 to 6, right? So we can do the same thing. Fit open parentheses 0, 1, 2.5 to 6. Okay, so that's good. Now this is vector x. Am I doing the same thing for the other axis? Yes, but I'm using the point positions another value, which is not the p. Okay, so I'm using actually p0, so we can, I think, do like this, p.x. Okay, so we're using the first component to generate a random number. Then we can, however, I don't want to, remember, I don't want to change the height, so we can do something like this. V at scale equals, so first we can define the value. So I'm going to say 10, 410. Okay, then I can use copy to points, with a standard sized box. Okay. So now it's basically using this value. Now I can say, I think I can just do this. Copy, paste. No, I think I need to use set. Was it like that? I think I need to go set. Vector x, vector x, float, and a little typo here. Okay, so now I have the vector x here, and I'm gonna create vector z. Vector z. I'm going to say use the z as a value, and now I'm going to say here z. This should give me somehow similar values, but it's not, but it's fine because we are evaluating this one by one. But it's doing the same thing. It's like, I think it's so much simpler. It's probably a better way to do it. Regardless, let's keep this one. So let's get rid of this one. I'm just going to keep this here in case I'm referencing it somewhere else, but obviously we don't need it. Okay, this is just so much more simpler. So next thing I'm going to do is that if there's anything intersecting, I want to get rid of those, because remember we're trying to make these fracture friendly. Boolean intersect. Save, please. Okay. Okay, we did the little cleanup there. So we are going to subtract this mesh towards this mesh if it's intersecting with anything. So after we fix the intersections, I think this wasn't necessary probably, but I think it was causing problem. All polygons, is it making a difference here? It kind of cleans itself up, and then I'm going to empty it. Boolean union. No, this one is not used. Get rid of this. So sorry, it's used here. Let's drop in a boolean. So we're gonna fix our edges now. After the boolean, this guy here. So which one is the? Let's say this one is create floors. No, let's call it subtract borders. Subtract borders. Subtract from borders. Then here we're going to subtract these edges that is coming from here. So we're going to use, these are now both volumes. Sorry, this left part is not a volume. Left part is the surface. Right side is a solid, and we're going to do subtract A from B to do a little bit more edge breakup like this. Okay, so it was like this. We got this object here, right? So just to break up the edges a bit more, so it's kind of a bit more interesting. Again, not necessarily, but you know, we're trying to create some sci-fi style look. Now what I also want here is to create another boolean. Now I want to find the intersecting parts. of my columns and my full geo, so it kind of gives me what's inside, right? Because here our heights are like here, sorry, everything goes outside, but this is kind of like within the limits. So if I visualize it like this, oops, that's not the node. Sorry, let's update now. This guy goes here. Okay, so these are new out floor here. So you know, it's a bit more interesting. I'm gonna put a normal SOP now to see it nicer actually. And if we do a merge, I think this now should contemplate the rest. Yeah, basically if I put a normal, I'm not putting a normal everywhere just to see how it looks, because not here, sorry, here. And if I put like this, it's a bit easier to see. So kind of our building coming together. So don't forget, this at the moment, if I remove, it's fracture friendly. If anything, we can just probably reduce the edges like really small, but no need. This is all fracture friendly at the moment, so we're keeping it to be fracture friendly as far as we can take it. All right, now we have these columns. They're not columns, they're just outer, let's say, edges. So I'm going to poly extrude these guys slightly larger by a unit of 1. And I'm going to boolean again. So this goes into the left input. This again goes into, I could have done this here actually, not very optimized. Again, both sides solid, subtract A from B. So what I'm doing now is basically getting a little silhouette that goes around. So it's kind of like a, because they're not columns, so it's almost like a how to say it, like covers around the walls. So if I merge it again to show you, it's kind of like layers. Oh, actually, yes, I can show you this. There is an image in one of the frozen frames on my website, and I'll show you which part this is. One second, please, it's coming. Yes, so these guys, those are these guys, these guys, these guys, these guys. Just adds a little bit of an extra detail, right? Let's continue. So when we do this boolean, I'm creating all these groups because I'm gonna blast things in and out. Okay, and I'm blasting B inside A, so put a blast. And if you want to check what they are, you can just say, you know, do this one by one. So this is the inside faces, so this will be the outside faces, and this will be like the whole thing. But now I'm blasting B inside A as it is like this, so I only keep the outside faces. Finally, I'm putting a normal SOP. Okay, and now I'm putting another measure SOP. And set it to area. Okay, so this is good. It's gonna give us the size of each of these faces, because we want to get rid of some of the small ones. Okay, but I'm gonna put a null now. I'm gonna say outsides. Okay, I'm going to save now and put a wrangle. Maybe organizes the area a little bit better, so this can stretch. These guys don't have to be so tight. Just checking the timer for the recording. Okay, so in 20 minutes, that's fine. Okay, now we want to add some detailed paneling. So I'm going to push this towards the left a little bit. Okay. What was the shortcut for adding points? Let me find that very quick. Well, I'm on Linux and I didn't change my super key, so this is what happens when I hold Alt. So I'm gonna put a null instead here, and I'm gonna say this guy here, and then this guy here is the same thing, and this guy here is the same thing. So it goes here, just to keep it a bit more clean. Okay, and let's organize this a bit better. Okay, I think that should do it. Let's bring this up. You go a little left, you go here. Okay, let's put this in a network box. Now let's drop in an object merge, and let's get this result in here. Size. You see, I'm not doing something like into this. In this level, this is not actually necessary. It's just my habit, I think. So it kind of, if you do an object transform, an object merge with this set to none, what happens is that it's going to keep the values if you have transforms here. Okay, but sometimes you want to zero those out. It's almost like deleting history, freeze points, or if you may, in Maya, I think freeze transformations. It's just a habit. In same network, you kind of don't have to do it. Let's continue. So what I want now is to get rid of some of these some of these remove, let's say small, and I'm just going to go quickly copy paste this. This is just going to remove anything that has a lesser surface area than 400 units. Okay, now I want the opposite of that here, which means anything bigger, and highly unlikely to have anything equal to 100. So just let's leave it like that. Okay, so now let's try to so there's a labs tool, actually, I think. I want to see if this works. Labs, because we're going to do the same thing. We're going to subdivide the mesh diagonally and horizontally to create some panel detail. Let me save it, and I believe I've seen a tool. Otherwise we're going to do this, but I think there is one already. So I am now in favor of trying tools that are available. Let me, however, see if it is available here. Where is the labs tools? Okay, let me try to find this. Otherwise we'll do it loops in loops. Probably it's better I do it that way, but let me quickly skim it. I am blind. I don't see it. Is it here? Oh, because I installed it. Okay, let me save. Let me reopen the file. because I have it visible on my other scene because I just updated it. It's under KineFX, or I was just not seeing it. Okay, it's opening. Let's open the scene again. This is the latest one, right? Give it a sec. Okay. Alright, so here should be the same guys. Let's try the labs. I wonder where it was. Labs, AV meshing, photo, no, texturing, no, no. Inside, no. No, not here, not here. Geo maybe. That's mesh slice maybe. I wonder what the name was. Labs taken, no labs, no, none of these. I remember I saw it somewhere. Detail mesh, this one. Let's try this one, because it kind of does the same thing. I have never used it. Let's see how it works. Template projection. I have no idea how this works. Okay, let's do something. No, I guess we don't use it like this. So what is this one? Required projection. Is it this? Can we use this? Okay, I shouldn't waste time like this. Let's do it the hard way. So I want to process each primitive. So for each primitive, I'll put a loop. Okay, let's put this here. So what it does is it fetches one primitive to process, right? And now for I want to add how to say it. I want to say this many times, do something with it. I'm gonna put another for each, this time by count. For each, oops, for each, do we have the feedback, or do we, for a loop with feedback? Okay, I'm gonna put this again here. I'm going to say by count, feedback each iteration. So for now it's 10 is fine. So it's going to do something with it 10 times, and it's going to feed it back. Okay, so if I do, for example, subdivide, if I do 1, and if I put this to 2, it's going to do the same thing twice. So if I say 1, it's going to subdivide once, right? It's going to take the result, it's going to subdivide again, it's going to take the result, it's going to subdivide again, so on and so forth. If I do this 2, then it becomes its power. Okay, so be careful with the slider now. We're not going to subdivide. What we're going to do is we're going to first create a direction based on the polyframe. So put a polyframe, goes in here. Say the tangent is now my new attribute called dir, like as in direction, first edge. What did it do? It did create this vector. So let's visualize that vector, see what that is. Okay, there's a way to nicely visualize custom attributes. You can right click on this guy and say I want to create a new common visualizer or scene visualizer, which is a marker. Okay, my attribute is there. So these are values now, but we are not interested in values at the moment. We're interested in vector trail. Or you got, there you go. So this is saying, oh, this is pointing this way, this is pointing this way, this way, this way. So if you look at the, for example, let's take an example of this one. So this is either 1 or -1 and 0 and 0, right? So let's have a look at the values. Can I make those bigger? Yes. Not so much big, but I think you can read it. I can't zoom in. Oh, I can do it from here as well. I think guides, scale, vectors, no, not the value, origin, point marker size, guide. Can I go? Is it a multiplier? No, it's not. This is the biggest I can get, apparently. Well, it's 0, -1, 0. Hence the not point trail, vector trail. Okay. Vector fixed color. You can choose directions to show you the color as well. Okay. Anyway, so this basically polyframe gives me. It checks the point number. If I go point number, and says, okay, 0 is here, 1 is here, 2 is here. It's like kind of pointing towards it. See, it's point 0 to 1 is pointing that way, 1 to 2 is pointing that way, pointing that way. So kind of like flowing a clockwise orientation. Anyway, let's continue. Now I want to do a clip. Okay, and in this clip, I want to be able to get the iteration value. So what I'm going to say is that in which feedback I am in, I create this create meta import node, and if I go to select it, and if I go here, it's going to get me the iteration value, which is 0 at the moment. So I want to use that to create some randomness. Now I always want to find where my cut point is. So basically I want to create a cut point between, let's say we're processing this here for this value. I want to say find my edge length and put a point randomly somewhere, and then do a clip, and then in another loop pick another one, do another one, which then will end up with a nice cut. So let's call this cut A. For this to work, I need to know my distances from edge to edge. These are little long values. So basically I'm just going to actually copy this so we don't type it again, and I'm going to disable this cut A. So at this point what I'm doing is, if you go to rendering parameter interface, you can see I added these extra floats. I have an iteration that is fetching the iteration value from the repeat begin one metadata. Then I have two edges, edge A and edge B, and it's measuring the distance from point 0 to point 1 and point 2 to point 3 and point 3 to point 4. 1 second. Point. This one is 1. This one is 2. Okay, so the distance. Let's open up the help. So you need to feed in three positions on one side and 3 positions on the other side. Okay, so what I'm doing is I'm saying get the point position of distance 0, the point 0. So let's close this. Let's close this as well. Here I'm saying here I'm filling it up. Say distance point 0 x point, this is x, point 0 sorry, on self, get the first point, which is in this case this one, get the position attribute, which is then it's looking for P, and I'm going to say take x is 0 because this one. Then I say the same thing, but I'm only changing 0 to 1, which makes it this one. Then I'm saying get the same point but get the z axis, which is now represented with the as a third vector, which is 0, 1, 2, right? So it's this one, -7 in this case. And I do the same with the next point, but this time point position 1. Okay, 2, 3. Anyway, let's now close this. This is cut A. And I do the same thing. So the distance is driven by a random value between the edge A, right? Because it gave me the distance, and I'm making sure that it's not on top of it by reducing it slightly, because it may end up on exactly on very small chance, but the cut point might end up on here exactly instead of somewhere here. Oops, I changed it. And I do the same thing, but this time diagonally with a cut B. I wonder if I can show this on here. It should show. It's not working. Oh, because we have one iteration. One second, let me turn this off. It's kind of working, but it has to process this guy as well. Okay, so let me see if I go here. Remove. Okay, so I think I will try to explain this a bit better. It's not very clear there. Anyway, so what I'm doing is I'm taking each one of these polygons and I'm creating random amount of cuts on X and Y, X, Z or Y axis, the amount I tell it here. So what happens is that when it processes it all, actually if I do this, it's going to be faster, like this to show you. Let's just select one guy from here, one guy from here, blast, keep, so it's just much faster. So if I go here, it basically created, it cut, so it created 1, 2, 3, 4, I think, because I have 2 here, no, 2, 1, 2. Okay, so if I go 1, you see it's kind of like just cuts them from the same place. We need to create an offset for that as well. 2, 3, 4. It's just creating random cuts. We just need, however, to randomize its position per, because it's always getting the same values. I guess we can then, I'm using iteration value here. We probably can use position. Let me see what happens if I use position instead. This one, 8p. It's still generating the same thing. Okay, we'll continue with that one. But we don't want this. Okay, so my current value is at 20. It's quite a high, but let's go. What happens if we do 10? Let it cook. It's making 1,783 cuts. Okay, so now we were here. Now we are here. So we have a lot of small tiny cuts. So now what I'm doing after these cuts is that I am putting a clean swap. Let it cook. And I'm doing a fix overlaps. Then I'm putting a cluster points. Cluster points. Its cluster is cluster amount is set to iterations times 2, and I'm calling this temp clusters. Temp clusters, okay, with the capital C. And I am this should be coming from repeat end 1. Basically it's gonna say if there is 10, make twice the size of clusters. It groups the it creates an attribute called cluster based on the let's run this first and then visualize the temp clusters. It's going to actually visualize itself because of the colors. Okay, now I'm going to just promote this. Let's turn off the colors, because in a loop now it's going to calculate every single time, so let's kill it. Let's put a promote, attribute promote. Okay, point to primitive temp clusters. Let's copy this. First match, and I think I am going to pack these now based on these cluster points to process based on their clusters. So I'm going to put an attribute wrangle and say cluster groups. Let's call it name groups, cluster name groups. Cluster name groups. Okay, and just gonna copy paste this. It's running on primitive. So what it did again? I mean, we did this already. I'm creating a new attribute called string this time, s string temp clusters, and itoa is integer to array because temp clusters are integers like 0, 1, 2, 3, 4, 5 because that's what cluster gives. Its output is an integer, so I'm converting it to an array so I can loop against it. But let's just run this for now because we're going to put another loop here. Okay, so if I put a color swap and if I visualize those primitive color attributes, random, I guess, would work. Temp cluster, oh, where is it? Temp cluster, temp cluster, temp. Let's have a look. Here, temp cluster. Temp cluster. Because it's an integer. Oh, okay. So let me do this so you can see it a bit better. It should have RAM format. This is correct. So it's not temp clusters. Temp clusters. Why it's not? It's just it should not showing be not RAM. Sorry, random. Okay. So just gave me a nice mosaic of colors. I don't think I use this for shading, but I think it was intended for shading use. Just to give it a little bit more randomization values, but not per primitive, but rather per loop, which kind of made more sense, I guess, at the time of the making. Then what I want to do is do a little cleanup now for the parts I don't use. So how am I going to do that? Because I created this temp. So basically what I want to do is, if it's the same color, I want to get rid of these lines. I want to get rid of these lines. I want to get rid of these lines within the same color. So kind of like an optimization Okay, so we really broke it down to smaller chunks, and now we're gonna up to, so if you focus here, so how do I do that? Because I have this attribute called temp clusters, and I created the name called as temp clusters, right? So I can create a for each loop again, and this time I can use for each name primitive. Let's kill this here, and then I can say use temp clusters, because this is the name we created, and then I can say it found, for example, the first one, right? Oops, wrong one. If I put this guy here and visualize it, its color, it's going to say, oh, okay, here it's not going, here at this object it didn't find, but if I go maybe do like this, change to this, okay, it's not finding because I have to bake this. Let's get rid of this, and now I'm just going to do that divide trick with the remove shared edges. Divide within the loop, right? So if I let this cook now, okay, let's visualize. Oh, I broke something. Oh no, here. Need to turn this off. So it processes the whole thing. Creating some edge detailing basically. Okay, if I zoom out and visualize the colors, I now have, I think if I, let me see, somewhere a bit more interesting, cuts, okay, maybe here. So I'm just going to disable this. I'm going to show before and after. So I have this shape here that is coming down like this. Previously, you can do middle mouse as well just to see the polygon count. $105. It's actually, I think, removing more than I wanted to, but let's have a look. Well, it really did remove a lot, so maybe turn this off as well. Let it cook to make sure you're okay. Okay, so I'm going to stick to this. The next thing I'm doing is to create a primitive swap. We can do this outside. I believe it's not randomized. We can go here and say, do a little transformation and scale me 1% smaller for each axis. So you kind of get these gaps to kind of create the little seams, basically. Okay. And then you can close this, put this in a box. Okay, and finally we are going to merge these down. We can do it on this side. Merge with the opposite side, right? This is what this is this. This should give me both ends. No, I'm doing something not right here. 1 second. This is remove. This is less than 100. This should be the opposite here. This is not working here. 1 1 second. This is less than 100. Did I not reverse it? And this should be bigger than 100. Okay, 1 second. There is a little confusion here. Okay, I think this is a better way to do it. Let's group them based on their sizes. Group by area. And you know this drop down, we have our preset snippets. So I'm just using point group on threshold, and I'm going to call this big. And I'm going to say if area is bigger than 100, just my same condition. And then it's going to say, oh, maybe there wasn't any 100 there. That's why it wasn't really setting it up. Oh, but these are primitive. So we go run on primitive. So it's going to say these are the primitive areas that are bigger than 100 units. So then it's also created me a big group. So what I'm going to do instead is that I'm going to put a split here. And oh, not split, sorry. Split, yes. And I'm going to put here big. So the left input will be how interesting. Okay, this didn't work again. Oh, because they're creating point groups. You need to create primitive groups. So let's say prim group, and based on primnum should be like this, I think. Yes, okay. So these are I think these would be the big ones. Therefore the right output should be the small ones. If I zoom in, small. Okay, let's go small. So now the question is, let's get rid of this. Big goes here. The input will be the opposite, so we can just drag this guy here. So now it should kind of, two of these should complete each other. Let's run this. I think we want to divide the small ones though, so let's reverse that, I think, selection. So maybe we connect the big one here, the small ones pass through, the big faces we put it in here. So we process the big faces, bigger faces. Let's go down. Am I losing volume somehow? I'm not sure what's going on. This is not this many small, oh, because we still have this guy. Get rid of this one now, finally. Okay, this should be okay. Now I can delete it because I already did that in my grouping. And I certainly don't want red color, so we can just get rid of this last part. Okay, so now if you want more detail, you can say run it. So if you do 2, it's less. If you do 20, which is the value in my scenes, it's gonna obviously run a bit more, but it's gonna do more cuts. Okay. Let's stop now this lesson as well. We're gonna move into part 3. Let's save the scene as is, and in part 3, so just to see in the context where we are and how similar it is to what we've been doing, what I did in my version. We just have a little less detail here, more detail here, but it's based on these parameters. Just keep playing with these. It will get you more different results. But we're kind of like in super close ballpark. There was a version difference, so I guess maybe there's some slight differences, but we are quite similar at the moment to what we've been doing. Then next thing we're going to do is we'll work on the windows, so which ends up being something like this. Just going to let it cook. So these are the frames for each floor. These are the glass for each floor. I think if you do this like this, then we are kind of creating little gaps to create some side walls to make it a bit more interesting. If I overlap, you'll see like this. So it's like, let's call these in the entertainment areas, common areas, you know, in the local condos. And in the next lesson again, we can do the inner walls. Let's let it cook again. Because we are doing destruction, so it's important to have inner walls. I'm just gonna turn off the UV part. So it's a lot faster. This is a bit, it slows it down a little bit. So as the detailing goes, obviously our calculation times are increasing. Okay, halfway through. $35, $42. Okay, so now we have inner walls, and there's some openings for doors as well, to be honest. We'll get there. So each room has a door. I didn't slap in a door geo, just a gap for now. We even have some lighting. I didn't use in my scene, but if you need, each room at the ceiling they have lights. Not the top floors, apparently. Need to fix that. And we'll create some columns. Ready to be destroyed. And some the out walls are here. They're coming. They're being extruded for destruction, I believe. Not here. Sorry, they'll get extruded later. And we have some antennas, because in future antennas are really important to make it look futuristic. All right, I'll stop the video and I'll see you in the next video.